Okay, very good morning to all of you. Today, I'm going to talk about ozone layer depletion. With the topic outlined I have here, first of all, we look at introduction, importance of ozone layer, ozone formation, destruction of ozone, how these ozones are actually destructed, concern on depletion of ozone, effects of ozone depletion, preventive measures for ozone depletion, latest development. Now, before we go to the main topic discussion, I just would like to give you a base view, overview of the Earth atmosphere. We have the lowest above the Earth surface known as troposphere, then followed by stratosphere, mesosphere, thermosphere, exosphere. And the exosphere is the outermost layer that is uh, a part of Earth atmosphere. And my topic discussion, ozone layer, actually falls between this troposphere and mesosphere, which is actually called as troposphere, which is at the height of 12 to 50 kilometers from Earth's surface. And when I discuss about this topic, we're going to discuss in relation to that layer. Introduction. Ozone layer was initially somewhere in 1913. It was discovered by French physicists Charles Fabry and Henry Boyson. This layer actually extends between 10 to 50 kilometers above the Earth's surface and acts as natural sunscreen, protect us from sun's harmful ultraviolet radiation. Ozone is measured in Dobson units, and one Dobson unit is defined to be 0.0 mm thickness at the standard temperature and pressure. Now, in 1985, an extreme depletion of ozone over Antarctica was discovered, and this is the problem. And in my presentation, we are going to discuss more or less. Most important part that we are going to focus is what we can do and what are some of the actions we can foresee to to combat this problem, which is actually the depletion of ozone. And here's a picture, here's a view that you can get and understand what is actually the ozone layer. And if you look at this diagram, we have two atmosphere actually is taken into two layers, the upper layer and the lower layer. So here the lower layer generally talks about atmospheric zone, where this air pollutant has a negative impact on human respiratory health. But above that, beyond that, we are going to discuss about the stratospheric zone, which is above the tropospheric zone, and this is very essential. And this actually serves as ozone layer, and this layer actually help us in protecting from dangerous UV exposure. To get more idea, I'll run through this presentation, and I'm sure you're going to get more picture as I continue explaining. Now, before we go to the other topic discussion, let us look at some of the importance of ozone layer. Ozone layer, what are the importance of ozone layer? First one is it keeps the earth warm by preventing the heat energy reflected by Earth's surface from being re-radiated into space. What it actually does is after the sunlight has been fall on the Earth try to radiate the light energy back. But this ozone layer acts as if like a blanket, whereby it actually keeps Earth warm. Another very important importance of ozone layer is ozone layer protects the Earth by blocking the harmful ultraviolet radiation. Ozone layer will try to protect this unwanted UV rays, which I will touch later on in details. What are some of the impacts of this ultraviolet ray? Ozone formation. Now, how this ozone are formed? Ozone. This is the general description. We'll touch upon how this ozone layer actually formed with the chemical reaction. Next slide. Ozone layer. Ozone. How this ozone actually is formed? First step. We should look at the first step is what happens is the oxygen molecule when it's exposed to the earth, to the sun radiation. What happens is break down into radical, and further this oxygen radical will try to react to combine with oxygen molecule, and this is how this ozone actually is formed. Look at this chemical reaction. You see there the sun rays fall on the oxygen molecule, it will break down into two radicals, further it reacts with, and then this is how the oxygen is actually ozone is formed. Now, having said that, ozone, we have understood how this ozone are actually formed, and there's another very important things that remember is destruction of ozone. There can be a natural destructions which it itself cannot control over it. We have no power to control over it. And the first one we are going to discuss is it happens naturally on the ozone stratosphere level. And what happens is this ozone reacts with the oxygen radical to form molecular oxygen. Ozone can also be recycled into molecular oxygen by reacting with. What happens is it happens naturally that on this after the formation of ozone, it's a natural continuous reaction. And what happens is this ozone will try to react with oxygen radical, and also they will form this oxygen molecule. And moreover, ozone when it's exposed to the sun radiation, what happens is it will again exposed to, it will try to convert to oxygen molecule, and this will actually continue process. And one interesting thing that you know is this process is not going to harm us, and it's not going to be very problematic in destruction and the formation of ozone. Next, now the biggest problem is the catalytic destruction. Catalytic destruction of ozone. Catalytic destruction. It is a man-made. It is artificial destruction caused by artificial means. And somewhere in 1960s, besides this natural destruction, scientists also have found out that there are some some pathways besides natural things. It also contains, and some of the catalytic species they have identified were hydroxyl radical, nitric oxide, and also those halogen atoms such as fluorine. Now let us look at how this hydroxyl radicals contribute to the destruction. This hydroxyl radical is one of the species that contribute to ozone destruction. What happens is this hydroxyl radical in a sphere will try to react with ozone, and they actually undergo reaction here. The reaction mechanism is shown there and laptop. So the hydroxyl radical will convert to hydroxyl peroxide radical, radical, and further it will undergo reaction mechanism step by step, and finally what happens is the oxygen radical will try to combine with the ozone, and then the product form is going to be oxygen molecule. Similarly, catalytic destruction of ozone by nitrogen monoxide, we simply call it nitric oxide. This nitric oxide will combine with ozone, and also it will actually undergo steps of reactions, and finally this oxygen radical that was formed or that has been produced from the nitrogen nitric oxide is going to combine with the ozone, and then this is how this molecule is formed. This is also how these ozones have been reduced in the atmosphere. And another very important ozone destruction is by chlorine. This is one of the major problem, and this is one of the very important to remember. So how does ozone also chlorine contribute to the destruction of ozone is if you see the steps there. This chlorofluorocarbon, we know that chlorofluorocarbon, that remember uh, some year in yeah, just a decade ago, we have a problem saying that the refrigerator that we use at our home is CFC, and this CFC actually contributes to the destruction of ozone. How it does that? And here, ozone hydrochloro, this chlorofluorocarbon is nothing but it consists of chlorine, and this carbon. Now, chlorine and fluorine. This chlorine actually is the main substance which contributes to the get this reaction where this chlorofluorocarbon is come into exposure to the light radiation. What happens is it is going to form chlorine radical. This chlorine radical further it will combine with the ozone, and then it will form chlorine monoxide. Further, if you look at the next step there, you see that the chlorine monoxide will combine with the oxygen radical, and then finally it forms the chlorine radical. Further, this chlorine radical, what it does is formation of chlorine radical. This ozone will try to combine with the oxygen radical, and then it form the the oxygen molecule, and in this way, the ozone that is present on the stratosphere has been just reduced with the help of chlorine radical. And point to remember, it has been established that each chlorine radical involved in change reaction has the potential to destroy 100,000 molecules of ozone before we carry it back to the troposphere. So what is trying to explain here is this chlorine radical actually will contribute in the formation of change reaction. It does not stop at that point. It will continue, and then this is how the ozone in the stratosphere is gradually decreasing. What are the ozone depleting substances? So these ozone depleting substances that in later parts we're going to discuss some of the examples in detail. These ozone depleting substances are those substances which actually contribute to the destruction. Look at this pie chart. We have these are some of the major substances which contribute to the ozone. Like the highest contributor is CFC12, and it's called CFC, CFC12, CFC113. Actually, all these products are the main substance which contribute to the ozone depletion. If you look at by the percentage there, CFC top the percentage 28%, followed by CFC 11 23%. And what you have to know from here is all these substances actually contribute to the ozone layer. And here are some more examples, some more depleting substance. That is one in the table. So can you go through this? They have this ozone depletion body. They have this can destroy the ozone potential of each of these chlorine gases. So for this chlorine gases, this reference they have taken is FC11 as 1, and others ice is taken as 1, and then in reference in relative to that CFC11, some other substances like this, well, CFC113 also contribute. Look at this another column, you'll see that global warming. What is that actually? It also contributes to the global warming. And most one interesting fact that you're going to see here is CFC contribute to the ozone rating much more than CFC. But global warming, if you look at the global warming potential, CFC is less compared to CFC2. What that means. And here are some other substances. Later on, I'll touch upon this hydrofluorocarbons. And this hydrofluorocarbon, interesting, hydrofluorocarbons actually do not contribute to the ozone depletion. It has very minimal, as it has a less potential in destroying the ozone layer. And that's the reason why I'll touch later on why these fish manufacturers has started using hydrofluorocarbon instead of CFC, fluorofluorocarbon. Now, let us look at the concentration of over the years. NASA, the reliable agency, all this scientific study, what they have seen is the concentration of ozone was fluctuating in a certain way. More than that, it was trying to decrease. The concentration of ozone was found to gradually decrease. Look at this. Somewhere in 1879, if you look at this graph, somewhere in 1979, the ozone layer concentration was somewhere above 200, which means 300 something units. But gradually, if you look at 1995, it has gone down to almost 50 above, only 60 something. And gradually, somewhere in 2017, this is concentration, uh, gradually increasing. If you compare with 1995, 2000, and then 2017, layer of ozone concentration is gradually reduced. Concern over depletion of protective. What to the concern? So by 1982, ozone over the Antarctica was found to be only shown already in the graph there. Normal requirement of ozone layer should be some 300. But the fact is, somewhere in starting 1982, they have observed that this ozone layer was now decreasing, and this is beyond the acceptable limit. This has provoked, this has the whole world raise the concern, and they also found out that this is going to be very, very risk, and it is going to be negative impacts gradually. So in somewhere in 1985, satellite image revealed a hole in the ozone layer over the sun. So in 1982, the layer was gradually decreased. After 3 years, how fast it is. If you look at this, 1982, now it's 1985. Somewhere in 1985, they found a hole in the ozone, largest ozone all over ever recorded as 29.5 million square meters. So it's also some highest record seen all in ozone layer. All was found, and this was the biggest problem. To get more idea, let us look at this. Over the years, NASA have observed this actually, and then if you look at somewhere in 1918, there was no hotel hole at all. You must wonder now which represent the hole. If you look at that, it's the diameter of that circle-like ring is keeping on increasing here. So which means if you look at 2001, the hole has this whole size in the circle has become large, which present that this is one of the highest hole, one of the as mentioned in 2006, somewhere in 2006 it was the highest. Then the zone has extended to cover an area of 10 million square miles in octopus. And this hole was gradually increasing and increasing. Now, what is the effects of ozone? We have seen that these layers are becoming thin and started to having hole from them. Now, what are the effects? What are the effects of depletion? Generally, there may be so many other effects of ozone layer depletion, but I'll just touch upon three. That is human effects to human effect to plants, amphibians, and marine life. So the effect of ozone depletion is the increased UVB radiation reaching Earth's surface, and this especially for human. These are some of the effects, some of the diseases it may cause. And look at this: sunburn, sun damaged skin, cataracts, no blindness, skin cancer. It is all mm, because of the depletion of ozone layer, where this UV radiation directly falls on our skin, eyes, and the list. This is actually likely to lead it. Plants, and if you look at the plants also, the leaves of these plants has become yellowish color, valuation color, which means the pigment of chlorophyll are disappearing because of this radiation, UV radiation. Things are happening in the plant's ecosystems. Amphibian and marine life. Ozone depletion, one of the leading causes of declining of amphibian species, leading to it's one of the problems. And some of the biologists who are working related closely with animals have observed that this kingdom animal amphibian species and some of them also have hot bases which actually have led to the decrease in their number, and they have also have these problems, eye problem and all, and this was observed. Ultraviolet rays can influence the survival rates of marine plankton, which eventually destroy animals. It's generally, if you look at this, everything that is existed on this earth are related, interrelated. We cannot make living by self, but we are interdependent. In this way, ecosystems have been listed. Now, the most important part is we have known the problem is there, the depletion has taken place, hole is there in the ozone layer. And now the preventive measures, this is very important. Measures that you have to take it to reduce, to combat ozone layer depletion. First, preventive measures that we can think of, or we can implement and try to activate is limit private vehicle driving. So uh, instead of this, maybe you can go for a pool vehicle or maybe by the public transport. Less is use of electric or hybrid vehicle will minimize the production of harmful gases. Use eco-friendly household cleaning programs, which is of less toxic, which is eco-friendly, and which are natural in nature. We have used this cleaning products. Avoid using pesticides. Pesticide, which we know it actually helps in more yield, but more than that, it actually will disturb the ecosystem. And moreover, the harmful gases, harmful chemicals, the chemicals that is present in the pesticide will contribute to the ozone layer depletion, and more importantly, it disrupt the ecosystem. Developing stringent regulation for rocket launches. This may not be true. This may not be the case in our context. And we hardly have any. We hardly, countries don't have rocket launching plans in Bhutan, but in other parts of the world, this has been one of the most dangerous contributing factor for look at the second point there. Our study shows that the harm caused by rocket launches outpace harm caused. We have been learning that CFC have been one of the most dangerous substances which contribute to the depletion. More than that, the rocket launches, the gases that even if you look at the dragon tails, smoke that has been produced by the very harmful. Another very important point is banning the use of dangerous nitrogen. This nitrogen is one of the. I think we have also discussed the catalytic reduction actually contributing to the ozone. More than that, they also contribute in acid like nitric acid, and this acid will actually disturb. And this acid, when it reaches the stratosphere, when they form, when they come into contact with the rain or water droplets, they will again ozone layer, and nitrous oxide is one of the dangerous, and it also contributes destruction of ozone layer. Besides that, there are some other preventive measures like minimize the use of fossil fuels, buy and use local products, and also afforestation. Self-explanatory. Afforestation, instead of cutting down the forest, conserve our forests and plant trees, which will help in the absorption of dangerous gases. It will absorb, minimize the content of dangerous poisonous gases. Yeah. So before we go to next topic, now let us look at one case study, not actually case study, uh, action taken by U.S. government to prevent the destruction of ozone layer. It's called as ban of supersonic plane. Let us look at. Um, so some year, so U.S. government. Look at this. In somewhere in 1960, considerable interest was shown in building a supersonic transport airplane that would be capable of flying in altitude of 17 to 20 kilometers. Because of the thin atmosphere in the stratosphere, supersonic plane would be capable of flying much faster than the conventional plane that we have till now. The supersonic plane was much faster, and it can fly much faster. This is the advantage that supersonic plane had. But having said that, when this supersonic aircraft would burn, this supersonic aircraft would burn 20,000 kg of jet fuel power and consequently emit 25,000 kg of water vapor, thereby potentially harming radical and 160 kg of nitrous oxide in each overall fight. Now we have already discussed this OH and nitric oxide, nitrogen monoxide becomes a very harmful. They undergo the catalytic reduction. Because of that, fears that this aircraft would further deplete the ozone layer that US government create the development of supersonic missiles. So this was the good initiative, the good action the US government has taken to combat the ozone depletion. Okay, now let us look at some of the latest development. What are the latest development that has taken place to combat, control this problem? International agreement on specific measures to be taken in the form of international treaty known as Montreal Protocol on Substances. Almost all the nation has come together and then be part of this treaty actually. Under this protocol, the first concrete step to save the ozone layer was taken by immediately agreeing to completely phase out chlorofluorocarbon, halogens, carbon tetrachloride, and methyl chloroform. So after forming this uh, Montreal Protocol agreement within the nations and the world, they have decided to phase out these unrequired chemicals. Instead of that, now alternatives to this substance, what they have used is started using petroleum solvent as a replacement for CFC 113 or 111 trichloroethane in cleaning application. Many household and personal aerosol products, for example, paint, sprays, and insecticides, now use hydrocarbons as propane instead of CFC. Another very interesting step they have taken in is in developing the refrigerator. In the olden days, in the previous production, then CFC. Now later on, after realizing the impacts, the negative impacts of CFC, they have developed the refrigerator using HCFs, which is very less ozone. And these are other some of the substances that they have cut out after the formation of this protocol. And if you get that banning of import and export of scheduled substances, which are not good for the ozone layer, they have and banning of import of local consumption of halogens, licensing of import of methyl bromide, banning of import of local consumption, licensing of import of banning of import of this are the, these are the latest action they have taken to fight against the ozone layer depletion problem. And finally, the conclusion here I would like to stress my presentation is harmful gases are the main cause of ozone depletion. It risks the life of living beings. As I have already shown there, it is going to be risky for the living beings. Protocols implemented and results are better. After the protocol implementation, the results has now generally it has become much better compared to the earlier scenario. Voluntary action for future generation. Whole world must join hands and create awareness to combat ozone layer depletion. We have to join our hands and fight against this. Very small effort could make a huge difference. Everyone, if we think it critically and if we think it positively and try to react it positively, this is going to benefit and this is going to make a huge difference in retaining the ozone layer as it was. And the one good news is as of September 18, 2019, ozone hole has decreased to 6.3 million square meters. Somewhere in 2001, it was mentioned that it was 10 billion square miles. Now, just after 10 years, it has which means and people have realized, acted upon, and the protocols implementation has brought certain positive impact, views of humans on this. So with this, I am done with my presentation, and I hope, though it's not very convenient like the classroom situation, I had to run all this slide presentation here and then speak instantly whatever I gather in my mind, and it made it that convincing. And then thank you so much for your time. And if you have any queries, if you have any question, any doubt, please feel free